Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. My name is Irina, and I'm the event planner for the Redmond Reactor. Sorry about that. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel, which brings us to today's session. The session will run approximately an hour and a half with questions throughout, and our speaker will do the introductions.
Okay, thank you, friends, for joining me on this session where we're going to talk about GitHub Actions and how to build and deploy applications to Azure by using this awesome technology. My name is Rodrigo Diaz-Concha. I'm a Microsoft Regional Director and Microsoft MVP for over a decade. And I'm also the Chief Software Architect of Lume, and I also work for other companies as well. And let's get into business, okay? So the link that I'm going to show you now is the one that I'll use the entire session because this is a Microsoft Learn module that explains how to use my GitHub Actions to build and deploy applications to Azure, right? So if you go to this website, then you'll find the Microsoft Learn module. So let me copy this and let me open a browser so I can show you this Microsoft Learn module. So I'm going to explain almost everything that this module has. However, I expect you to follow the steps and do the module by yourself. Of course, you can do it right now, or you can follow along through the entire session, or you can do your exercises and read the documentation after the session is over, okay? So let me go back to the presentation because I want to explain some concepts around GitHub Actions. But before we do that, let me explain what is continuous delivery, because GitHub Actions is a platform and a technology that allows us to create continuous delivery and continuous integration pipelines that we can use to deliver software very rapidly, okay? So what in the world is continuous delivery? Well, continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time, okay? This is description from Martin Fowler, and I think it hits the nail because it describes perfectly what this process is all about. It's all about delivering software very rapidly and with the highest quality as possible. Okay, so let's pretend that we work in a software development company, okay? Maybe you work with some other peers, you have a development team that you work on a shared code base. And of course you have your PC, right? You have your local environment, maybe you're using Windows, maybe you're using Linux. Actually, it doesn't matter. CI and CD pipelines is the same for any kind of development environment and programming languages and platforms, okay? So for instance, if you work on these kind of environments and teams, you are developing your applications locally, okay? So maybe you're using Docker containers for containerizing your code. And of course, you're doing that locally. And then you decide that it's time for you to commit your changes to the main repo, okay? So you decide to commit the changes by using git push, for instance, or of course you can create a pull request, and it depends on the flow that you are required to do in your own company, right? And of course we use GitHub for or as the technology and platform for storing the code bases. GitHub is it's a company, of course, that allows us to create projects, public projects, and also private projects, right? It doesn't matter if it's a private or public project. We can use GitHub Actions for any kind of project. Okay, so you decide to commit your changes, and then you trigger your CI/CD pipelines for maybe compiling the application, maybe for creating some Docker container images, for testing your code, for, I don't know, for deploying on a staging environment or whatnot, okay? So finally, when you run those processes and tasks, you decide to deploy your application, maybe to a cloud or maybe to an on-premises environment. Actually, it doesn't matter. CI/CD pipelines allow you to deploy your application any place you want or need, okay? So basically, this is the workflow that almost any developer nowadays uses for delivering the software. What would be another option for doing this? Okay, well, we can, of course, compile the application and copy those binaries to, to a USB drive, or we can share those binaries in a shared folder or whatnot. However, that's not the way that we should build and deploy software, right? Because that's a manual process, and it has the potential problem of, missing some steps along the way. So with CI/CD pipelines, we can manage and we can deliver software very rapidly and automatically and with higher quality. Okay, cool. So CI/CD, it's a great topic, right? And we should strive for using those. And GitHub Actions is a technology, it's a platform of this kind of CI/CD pipelines that we can use. So GitHub Actions allows us to automate our build and test and deploy our deployment pipeline. Okay, so as is here in the screen, GitHub Actions is a CI/CD platform that allows you to, actually that's a typo there, to automate your build, test, and deployment pipeline. Okay, that allows you to automate. Okay, cool. So it's all about automation. It's all about delivering software in a more rapid pace. And this is the name of the technology, GitHub Actions with capital A. Please don't get confused with Action with lowercase a, because that's a package script to automate tasks. Okay, so for instance, we use the GitHub Actions technology, and we use a lot of different GitHub Actions with lowercase a to specify what would be the tasks that we want to execute when triggering those CI/CD pipelines. Okay, so I'm telling you this because it's quite confusing, because some of the times we're using GitHub Actions as for naming the technology and the platform, and some other times we use GitHub Action as for referring to those small scripts that have some kind of behavior for performing something. And I'm going to show you a lot of actions here in this session. Okay. So to understand GitHub Actions, first, we need to understand the different components that this technology has. So for instance, we in GitHub Actions as a platform, we have workflows, okay? Workflows are the unit of automation that we use, okay? So for instance, if you create a new workflow, what you're doing is specifying all the different jobs and steps and actions that workflow will have. So for example, here in the screen, we can see that I have this workflow named a workflow for my hello world file. That's just, it could be any name. And there's a trigger involved. The trigger specifies how how we can execute this workflow, how we can trigger this workflow. We can trigger a workflow by using a GitHub push, or we can use a pull request, or maybe we can use some kind of detection about the labels that we're using in the code, or whatnot. I'm going to talk about that more later in this session, okay? So a workflow has one or more jobs, and a job is a group of different steps that we want to execute as a unit. Okay, for instance, here in this diagram, I have this build job. The name could be anything you like. In this case, this example has the build name. And inside the job, we have one or more steps. And steps are a group of different actions that we want to execute. For instance, in this diagram, this step that we have on the screen, it's performing and it's executing a couple of actions, okay? The first one is the checkout action, and the second one is the action A, okay? It's just one small example about this. And there's another concept related to this, which is the runner, okay? You can see inside the job that it has the runs on element, and it's using Ubuntu latest as the runner. This is the name of the environment that you want to use. For instance, of course, Ubuntu is a Linux-based operating system, but we can also use Windows. We can also use Mac OS. Those are the names that some virtual machines that GitHub exposes, they have those names, okay? So I'm going to show you the entire list of runners that we can use. But this is important because if you're building, let's say you're running a Windows-only application that is using, let's say, the .NET framework, then you need to use a runner that has the Windows operating system, right? Because .NET framework is not a cross-platform technology. On the other hand, if you're using some kind of cross-platform development platform such as Node, or let's say Java or .NET Core, then you can use any other operating system such as the one that I'm showing you here on the screen, which is Ubuntu latest, okay? So for instance, workflows are the automation unit. They have one or more jobs, and they can be started manually or automatically. And most of the time, we want them to run automatically as the result of some trigger, some external event that happened, okay? And generally speaking, you want to do that every time you check in your code, okay? But of course, you can configure that to use any kind of trigger you want. So you specify how to run your workflow by using the on element, just like the code that we have here on the screen, okay? On, and then the name of the trigger that you want, okay? So the workflows, physically speaking, are YAML files, okay? So in order to take advantage of GitHub Actions as a platform, I recommend to you to understand the YAML syntax. YAML is a markup language, yet another markup language. That's the acronym of this language. And it's a very easy syntax to learn. However, just take into consideration that you have to use that language to specify and describe your workflows. And you're going to store them in the .github/workflows folder inside your repo, okay? So I'm going to do that in a minute. Before we do that, let me explain again jobs. Jobs, as I said before, are one or more steps, and jobs execute on the same runner. Okay, so for instance, if you say, hey, I want to build this .NET application, and I'm specifying Ubuntu latest. Okay, so the job that has those actions to build the applications, those actions are going to execute on the same runner because those actions are in the same job. Okay, so another important concept around this is that jobs, every time you hit one job and you reach a job inside your workflow, a new VM instance will be executed. So you'll have an entire clean environment for your to run your different actions. Okay, so that's important because you cannot directly share data between jobs because of this. Because every time a new job is executing, then you'll have a new VM instance. That's why. So steps are one or more actions, and steps can have, of course, actions, and they can have scripts. Scripts written in the well, with the syntax that your shell understands. Of course, if you're using Ubuntu latest, then you have to write your scripts by using Bash or something compatible with that operating system. And on the other hand, if you're using Windows, then you can use PowerShell or whatnot, okay? So, and finally, actions are those small packages, those scripts that are per-build, and those actions are created by GitHub, the company, or they could be created by the community. Okay, and you can also write your own actions if you want. Okay, there are like hundreds and hundreds of actions that we can use in our own CI/CD pipelines. There are some examples here in the screen, such as checkout, setup.net, setup node, Azure login, Azure Docker login, and as I said, there are hundreds and hundreds of actions. Okay. And okay, before we go to the portal, let me tell you about two types of actions that we can use. There are some Docker container actions, and there are other kind of actions that are JavaScript based. Okay, so for instance, Docker container actions, they have the environment as part of the code, and because of that, those are more consistent and reliable. Because you don't need external dependencies, that's why they are more consistent. And of course, they can only execute with runners that have Linux-based operating systems. And on the other hand, JavaScript actions, they can run directly on a runner machine. You can use, and you must use JavaScript language for specifying those actions, and they don't include the environment in the code. Okay, so those are the two types of actions that we have here in this GitHub Actions platform. Okay, so let me go back to the browser because I want to show you a lot of things. First, let me show you the exercise that is related to this session. So after you read the introduction and you read about GitHub Actions, how to deploy to Azure, blah blah blah, and there's some interesting topics here. At the end of this, we can find the exercise. So let me go straight to the exercise, and here you're going to click on this Start the Learning Lab on GitHub, and this will deploy an entire repo on your account, and it will guide you through different steps for creating this kind of CI/CD pipelines, and then you're going to deploy the application that you're building to Azure. Okay, so for instance, you follow those steps, and they have a lot of different explanations and descriptions. Okay, so you follow that and you will be able to finish the exercise. However, I want you to see how in the world um, GitHub Actions are created in a greenfield project, okay? Because in the exercise you are given a lot of different files, and that's why I want you to see how to create GitHub Actions from scratch, okay? So for instance, I have this repo that I already cloned in my machine. As you can see here, I have this code that is based on training course about microservices, and I don't have any remote, okay, right now. What I'm going to do now is to go back to the browser, and here I want to create a new repo, okay? Let me go here and do that in another screen for privacy concerns. Let me do that. I'm going to create this repo. Okay, new, okay, I can show you this. So the repository name that I'll use is, let's say, GitHub Actions Reactor, okay? So GitHub Actions Reactor, that's the name of the repository that I'm going to deploy. And I'm just going to create this repository, okay? And I'm going to push an existing repository from the command line because I want to push this code that I have here, okay? Because I need some kind of code to build an application and use those GitHub Actions, right? Okay, so now I want to push all the changes, and I think we should have code here. Okay, so cool. Why I did that is because I didn't want to do that in the same repository as the one from the training course, okay? So if I go here in the Actions tab, you will be able to create new workflows. As you can see here, I already have one, but just please forget about this. I want to show you a new one from scratch. So when you click on the New Workflow button, you'll see this Choose a Workflow webpage. And this is important because GitHub is gonna analyze your code, and it will give you and suggest you template that is probably good for your code. Okay, so for instance, GitHub analyzed my repository, and it analyzed that it's based on .NET and it's using C#, of course. And here I'm going to use this suggestion, which is the .NET template. So I'm going to click on Configure, and here I'm going to create this particular workflow, okay, inside the .github folder, and then workflows, and the name of the file will be .NET. Of course, you can rename this as, let's say, my .NET or whatnot, okay? So here in the web page, you need to specify all the different workflow configuration and the jobs, steps, and actions that I just mentioned before in this session, right? So for instance, if you see the code that is already implemented by the template, you can see that this trigger will be triggered and executed by means of a push or by a pull request in this particular branch. And it has different actions already in place, such as .NET Build, .NET Restore, .NET Test. Those are processes and tasks that we do as .NET developers. Of course, that's because I'm a .NET developer. But of course, if you're using, let's say, Node or Java or any other programming language, then of course those actions will be different, okay? However, this is great because the template has almost everything that I need to compile this application. and to build this application, okay? So another thing is that you can see that I'm using this Ubuntu latest runner, which is a Linux-based operating system. And there are some other things that are happening here, okay? Cool. So what I'm going to do now is commit this change and let the workflow run. So if I go back to actions, then you'll see that the workflow will run, okay? You'll see that the workflow is running right now, actually. We can see that here in this icon, this animated icon is telling me that this workflow is running, okay? You can inspect what's going on inside this workflow if you click on the name of the workflow and you navigate to this detail page, and you can see on the left the list of different jobs that this particular workflow has. Okay, for instance, I have the build job. And inside the build job, I have different steps, and each step has one or more actions. And I can see that some steps are successful, and I can see that a particular step wasn't successful at all. In this case, the test step. So this is the regular workflow that we use when specifying GitHub Actions, okay? We can see that the workflow is running. Maybe the workflow was successful or not. And if it wasn't successful, we can go back and, just fix the error. In this case, if I click on the build job and then I navigate here in the test step, I can see that the problem is that this is expecting a particular version of .NET. And this is because the code that is using this repo, this e-commerce fictitious project is using .NET Core. And maybe in this runner, I don't have .NET Core installed. So we can go here and let me show you the workflow file because I want to fix this or maybe attempt to fix this. And in the meantime, I want to show you some other concepts around the workflow and GitHub Actions. Okay, so we can see the YAML file. We can see the YAML syntax here. We can see that it's a workflow that has this build job, and it's using these different steps, and it's using some actions. If you go here in the right side of the web page, you can find the GitHub Actions Marketplace, which is a place for you to search for actions. Maybe you wanna, let's say, you wanna package your binaries in such way. Maybe you need them in a zip format, or I don't know, maybe another format, or maybe you want to add some particular code analysis tool. For example, you can use SonarQube or whatnot, right? So for instance, here, you can search for any kind of different tasks that you need to use in your own CI/CD pipelines. In this case, the workflow, okay? So for instance, I could use SonarQube to analyze the code, etc. If you click on a particular action, then you'll see the code that it's required for you to insert in your own workflow file, okay? So it's the same if you search for, let's say, .NET, and now I want to, let's say, search for .NET with a dot, and let's say that I want to use this setup.NET Core SDK because maybe the problem that I'm facing right now is that the runner doesn't have .NET Core 3.1, which is the version that I used when I created that demo application. So you can go here and insert the code in the place that it makes sense. For instance, let's say that I want to use it right here, then you can copy this and paste it right here and just change the different values of that are required for this action, okay? So that's the workflow. It's not my main goal right now to fix this. Just take into account that this is expected because you need to specify each of the steps that you want to execute in your own CI/CD pipeline. Okay. Okay, so another thing that I want to show you right now is the list of virtual machine types. In other words, the runners, okay? Ubuntu latest, Ubuntu 18, or Ubuntu 16. Those are the ones available for Linux. And you can also use Windows latest or Windows 2019, or even you can use Mac OS. Why? Because if you're building, let's say, an iOS application or an iPad application or whatnot, then you will need this runner for you to compile and build and even deploy your application. So that's great. We can use those different operating systems. Okay, cool. So let me go back here and let me show you and explain to you some other topics, and not right here. Actually, I'm gonna go back to the presentation. Okay, cool. So that's awesome. We have so many different actions that we can use. Those are already created by GitHub or the community, okay? And there are two types of actions. Some of them are Docker container actions. Some others are JavaScript actions. Okay, runners, again, those runners are the virtual machines that run your workflows, okay? So you specify that by using the runs on element. So for instance, if I go back to the browser, I was using Ubuntu latest, right? So let me go back here, runs on Ubuntu latest. And be sure and keep in mind that this is an element that is inside the job, because each job has its own runner. For instance, you can have a job that is running on Linux, and you can have another different job that runs on, let's say, Windows, okay? So I already explained this, and let's explain now artifacts. Artifacts in the GitHub Actions world are the results of a workflow. Let's say that you're building or compiling an application, and you are creating some binaries. So those are called artifacts in the GitHub Actions context, okay? And those artifacts or binaries will be stored on GitHub for 90 days, okay? And why this is important, because as you might remember, I said that when you are running a job, when a job is executing, a new virtual machine instance was a provision for you, right? So there's no way to share between jobs data somehow. So you need some kind of middle ground. You need some kind of shared storage for you to, to use those artifacts in different jobs. That's why we can use those artifacts, and we can use artifacts for other things as well. Keep in mind this other topic, which is the usage limits. And of course, GitHub is free and it gives you a lot of power. However, there are some GitHub plans for enterprises and for larger teams, and it makes sense, right? And here in the screen, we can see the different plans that GitHub has. And of course, I'm running the GitHub free plan because I have that plan in my account. However, it will depend on your company. And if you have the different plan, then maybe you will have different total concurrent jobs that you can execute, and you can have different power, right, to execute those CI/CD pipelines. Awesome. I spoke about workflow execution. Those workflows can be executed manually, and we can also execute the workflows by using triggers. If I go back here to the browser, we can see that this particular workflow is using the push trigger and also the pull request trigger, right? And those are two ways for this workflow to execute, okay? And you can have any number of different triggers, okay? And let me go back here to the presentation. And we also can use different events, external events, to execute and trigger those workflows. For example, you can use like a chat ops way of doing things. In other words, you can create this application for Slack or Microsoft Teams that accepts some commands. And if you type the command, let's say build application, blah, 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 then you can execute that workflow externally. Okay, that's the another option that we have. So, okay, this is cool. Let's go back to the exercises and let's go back to the documentation because I want to show you what's going on here. So you're going to create this fictitious application, right? And let me do this. Let me do this because I want to show you from the beginning, okay? I already showed you how to create a GitHub Action workflow by using the portal, okay? And then in the portal, you can write the YAML code for your workflow. Of course, you can edit your code in another editor, such as Visual Studio Code or Visual Studio or Notepad or whatnot. Because typing YAML code in the browser, maybe it's not the best experience, right? So, okay, after you read the exercises and you understand the topics that I'm describing and more, some others, of course, then you'll reach the exercise. You'll click on the Start Free course, and then you should click on the Begin GitHub Actions Continuous Delivery with Azure button, okay? So this is gonna create a repo that is going to have the exercise. So this is giving me an error because I already done that, which is odd. I already deleted the repo. Let me go back here and go to settings and let's say delete this repository. I'm going to delete this, blah, blah, blah. Yes, I'm sure I want to delete this. Let me go back here because I need to type my password. And again, this is because I already had that that repository in place, okay? That's the reason why, because I already taught this course in the past. Cool. Let me go again here. Let's refresh the page. And let's now click again on the Start Free course and let's expect, yeah, okay, it's running right now, okay? So this is the same experience that you'll have if you follow along, okay? So you start step by step and it's going to describe what is continuous delivery. We've already explained that. And it's gonna explain some other things, such as how to execute the workflows. And you will be required to create your first workflow named deploy staging.yaml in this particular place. So that's why I decided first to create a workflow from scratch, because there are so many things here already in place. And I personally believe that it's quite confusing sometimes. So I think it's better for us to understand how to create those from scratch and what are those different components that GitHub Actions have, okay? So here you'll need to create your YAML file, and you'll need to change this folder to workflows and name the file deploy staging, okay, just like this. As you can see, this is a workflow, very easy workflow, right? There's nothing in it right now. So I'm going to commit the changes, and then I can go back here, and the exercise is going to tell me what else to do. Actually, I needed to insert this. So I'm going to go back here, and I'm going to edit the file. I actually messed up with this. However, let me see if I can do this right, okay? So you're required to use the code that the exercise has, and you're going to paste the code here. Of course, you can type everything. However, for time purposes, I think it's better just to copy the text and paste it right here. So as you can see, this other workflow that the exercise is giving us, it's using the pull request trigger, right? However, it's filtering out those pull requests that have the label types. In other words, in this particular application, in this particular workflow, you're going to execute the workflow if the workflow, I mean, if the repo, if the commit of the repo has a particular label, okay? That's why you're using this. Of course, there's an entire description around that in the documentation, okay? So let me commit the changes again. And if we go back here, then it's going to detect that everything is done. And I just refresh the page, and there's another step that we can, or we should use, right? So for instance, here in this other step in the exercise is telling us about job conditionals. What are job conditionals? So let me go back to the presentation, okay? I'm sorry about that. Cool. So before I explain this, let me see if there are some comments. Is it possible to remove the speaker video window so the screen text is bigger? Yeah, I think we can do that. Okay.
I took care of it already.
Yeah, cool. Thank you. There's another question. How does GitHub Actions compare to using Azure DevOps? Thanks. That's a great question. So, GitHub Actions is more recent than Azure DevOps. So, Azure DevOps is the evolution of Team Foundation Server, right? You might remember TFS. So then it became visualstudio.com in the past, like 10 years ago, which was quite confusing, visualstudio.com. And then Microsoft decided to rename that to Azure DevOps, okay? So I think it's a more robust platform, Azure DevOps, because of the fact that it has more time in the market, just because of that, okay? So for instance, in Azure DevOps, there are hundreds and hundreds of different tasks that you can use, and maybe those are not available in GitHub Actions. So that would be a difference. However, GitHub was acquired by Microsoft like 2 years ago, 3 years ago. I don't remember because of the pandemic. You know, everyone lost track of the time. Anyway, Microsoft acquired GitHub, and GitHub is the largest platform that has repositories of code, right, in the world. So I think that GitHub Actions, they have different behaviors and features that are evolving in a more rapid pace than Azure DevOps. So, I mean, those are two different technologies. However, if I were you, I would start using GitHub Actions if it makes sense for your projects and company. Okay. However, maybe your company is already using Azure DevOps. In that case, it doesn't make sense to go and migrate everything to GitHub. Okay. So stay in Azure DevOps and you'll be fine. Okay. So it looks like those two are competing platforms. However, I think those two are great feature-rich technologies and ecosystems. So anyways, let's go back to the code, shall we? Okay, so the exercise in the workflow is gonna explain to you, hey, in the workflow, we're going to use some conditionals, blah, blah, blah. And the conditionals are great because they allow you to specify if a certain condition is met, then you want to execute the job in this case. So for instance, if we see the code that is in the screen, we can see that if github.ref equals to blah, 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 then it's gonna execute. So that's how you use conditionals in workflows, which is great, again, because you can execute some steps and some actions in terms of those conditionals, okay? So that's why in the exercise, the conditionals are used because, as I said, the exercise is going to filter out the pull requests that have a particular label, okay? So there's another example here. Actually, I think this is the same code that you're going to do in the exercise. If contains, please take care of this, okay? Contains is a function that you can use inside your YAML file. There are so many different functions that we can use in the YAML file that GitHub Actions understand, okay? Contains is just one example of a function that we can use. So, for instance, this is validating that if in the label name we have the stage string, then you will be able to run the entire job, okay? So those are the conditionals that we can use in our code. So here's some explanation around that. Contains is a function that allows us to determine if a value, like say a label named peacock, is contained within a set of values, blah, blah, blah. So the same as I already mentioned. Cool. So now let me do this. Okay, you're going to do this as well. So you're required to specify the labels and you will be required to do some other things. So I'm going to copy the entire code that you need to change in the workflow file. So we can just paste the code. And this is interesting because as I said, this is using the label trigger, okay? And this is evaluating if stage is included in the name of the label, okay? Of course, there are some objects that we need to understand. However, because of time constraints, I'm not going to explain every single object that we have. Of course, the documentation has that explanation, okay? So I'm going to commit these changes. And I'm going to go back here, and this is going to detect that the changes already saved. then we're faced with another step. In this case, we need to specify the environment, okay? So here is the place that we use Azure, okay? So for instance, if you want to follow along this exercise, you'll need an Azure subscription, and of course you need a GitHub account, right? So how in the world we communicate between GitHub Actions and Azure? Because let's say that we want to deploy the application that we are creating into an Azure resource, right? So what we do is we use this AZADSP create for RBAC command. We use the Azure command line interface that I suggest you to install in your own machine, because you can run the Azure Cloud Shell inside the portal. However, I think it's better if you install the Azure command line interface, okay, which is this AZ command, okay. At the time of this recording, I'm using the 2.35 version. I think there's a newest version right now available, okay? So this command, Active Directory, Service Principal, create for RBAC, this is the way that, this is not a GitHub Actions topic, okay? This is an Azure topic. And this is the way that we use to authenticate from external systems, okay? This is one way to do that. So we create this service principal, and we give permissions to that service principal object inside Azure. And then this is gonna give you an entire JSON object that you can use as the credentials, okay, for your application. And this is the most important thing here. You need to store that credentials inside your secrets, okay? This is not a great idea to use directly in the code. For instance, you don't want to use this, of course, this is a fictitious JSON credential document, right? However, if you execute this, okay, you will receive a JSON document, okay, a fragment. It's not a good idea to use that fragment directly in the code, because you're going to be, you know, exposing those credentials to the entire world. So it makes sense for you to store the credentials in a secure way. And that secure way is the GitHub Secrets, okay? So if you go to the repo, in this case, GitHub Actions Continuous Delivery Azure, okay, which is the repo that the exercise created for me. If you go here, you can find this secrets option. And if you click on the secrets option, then here in the actions item, you can create your own secrets. This is the most important thing about how to communicate between GitHub Actions and Azure, okay? So you'll create first an Azure subscription ID, okay? Which is the unique ID of your Azure subscription, okay? So I'm going to duplicate this, and I'm going to do that in another window because of course, privacy concerns. And I'm going to paste this, and I can show you right now. If I refresh the page here, you can see that I created this Azure subscription ID in another window, of course. And you'll also create a new, the Azure credential secret that has that entire JSON fragment, okay? That has the application ID, it has a display name, it has a password, and also a tenant ID, okay? That's why I'm not showing you this. However, let me go here and add secret, and let me go back here. And as you can see, I created these Azure credentials, okay? Cool. So that's the way that we use the service principals from Azure, those credentials that the Azure command line interface it's giving me. And we store those secrets in GitHub Secrets, okay? And we're ready to use that in the code. Actually, if we see the code here, and let me open this in a new tab, and paste everything, you can see that this will be used. I mean, those secrets will be used in the code with this particular syntax, okay? Let me increase the font size so you can read better, okay? So as you can see here, this particular action is Azure login, okay? It's just the way that you need to authenticate to Azure, okay? Azure login, okay? Of course, there are many other different properties that we can use in this particular action. However, this is using the creds property, okay? And in the creds property, we're reading the secret that we created, and we are using that value as the value for this property, okay? So this is the way that we manage to communicate between those technologies and platforms, GitHub Actions and Azure, okay? So here it's using Azure credentials, and there must be another place where the Azure ID is being used. I can find it right now. However, it doesn't matter in this moment, okay? Okay, so you're going to do this, and then you're going to, of course, commit the changes, and this workflow will be ready to deploy the resource to action, to Azure, okay? So in this case, it's going to create a new web app container that has this name, this endpoint address, okay? And at the end, it's going to execute AZ logout, just as you can see. This is running the Azure command line interface that I already showed you before. Cool. So if I commit those changes, what would happen? Credentials at secret, I think we're done here, okay? So, of course, I'm required to merge this, and I'm going to confirm the merge, and then you'll continue with the exercise, okay? By specifying the name of the labels, and then you're going to create some pull requests with a label and some other pull requests that have other labels, okay? Cool. So if we refresh this exercise steps, we can see that we are in this particular place in the entire exercise. Of course, the rest is for you to continue as a homework, right? And as a summary, let me go back here. Okay, before I say the summary, let me tell you about a couple of things. Workflow templates, those could be created in the root of the repo. If you're in a company that want to have like a base template for all your workflows, you can do that, okay? And action versioning. This is important as well. Let me explain to you this very rapidly, because if I go back here and I show you the code, you can see that some actions have the add v1, add v2, add v3, what have you, okay? So this is the version that we want to use for this particular action, okay? This is for specifying the specific version that you want to use for that action, okay? And the best practice is to do that because as we can read here in the screen, it's a good practice to use a specific version of the action so we can protect ourselves against unexpected changes that may break the workflow. And it makes sense, right? Let's suppose that the owner or creator of a particular action releases version 1 and then releases version 2 with some breaking changes. So if you didn't have specific version 1 in your code, then you're going to you're going to break your code, right? You're going to have some problems, some serious problems. That's what I'm talking about here. Cool, GitHub Secrets. I already explained that. We use this particular syntax for referring to those secrets. And the secrets prefix, it's an object, okay? That's an object that I want to see in this table because we have different objects that we can use. Those are named contexts, okay? So I'm using the secrets context, and it has different properties and objects that we can use inside the secrets context. And of course, there are so many that we can use in our code. For instance, we can use, let's say, env for reading the environment variables. We can use the runner object to read the different values and understand the properties that the current runner has, and some other context, as you can see here on the screen. Cool. So again, I'm going to show you the URL that I want you to navigate to, because that's the place where you're going to read the entire documentation about the exercise. And of course, the exercise that you can run by yourself in your own GitHub account. Maybe you'll need like a couple of hours. Maybe you'll need, let's say, yeah, maybe 2.5 hours to finish the entire exercise. However, it's a great way to understand and to learn about GitHub Actions and how to deploy to Azure. Summary, the most important thing to understand about how to deploy resources to Azure is to use those service principals, okay? And you store those credentials in the secrets storage of GitHub. And okay, I think we're done for now, and I can understand. I can respond to any questions that you might have. Server was formerly called TFS. Services was formerly called VSTS, and before that, VS Online. Yeah, that's right. That's the story, right? Yeah, I was missing the VSTS. TFS, then VS Online, Visual Studio Online, and then VSTS. That's right. Anyways, naming is hard, right? And I mean, Azure DevOps, it's not the perfect name. However, I think it's better than Visual Studio Online. To view okay, cool. So please let me know if you have an additional question, and I'll be here to respond.
While we wait for more questions, if anyone has any feedback, we'd love to hear what you have to say. I've added our survey to the screen as well as into the chat. For this specific event, it's 15876. We'd love to hear what you have to say. Thank you. If anyone has any questions, please add them into the chat.
Thank you. Gracias, Victor. If there are no other questions, thank you for coming, and see you in the next Microsoft Reactor sessions. Okay? Bye-bye.
We have a nice session before you take off. Thank you so much for joining us. Thank you, everyone. Until next time. Goodbye.
Bye.